The 19th century witnessed the birth of the scientific understanding of the greenhouse effect and the potential implications of human activity on the Earth's climate. While the concept of climate change as we know it today was still decades away, the groundwork was laid by a series of pioneering scientists whose discoveries and theories paved the way for our modern comprehension of this complex phenomenon. In 1824, French mathematician and physicist Joseph Fourier published his work on the Earth's temperature, proposing that the atmosphere acts as an insulating layer, trapping heat from the sun's rays. This early description of what we now call the greenhouse effect was a significant breakthrough in understanding the Earth's heat balance. Fourier's theories challenged the prevailing notion that the Earth's temperature was solely determined by the balance between incoming solar radiation and the heat radiated back into space. He recognized the crucial role played by the atmosphere in regulating the planet's temperature, likening it to a greenhouse's glass panes that allow sunlight to penetrate but prevent the escape of heat. While Fourier's work laid the conceptual foundation, he could not fully explain the mechanisms behind the atmospheric heat-trapping phenomenon, as the specific gases responsible were yet to be identified. Nearly 4 decades after Fourier's groundbreaking work, Irish physicist John Tyndall conducted a series of experiments that identified the specific gases responsible for the greenhouse effect. In 1859, Tyndall published his findings, demonstrating that certain gases, including carbon dioxide and methane, have the ability to absorb and trap infrared radiation, effectively insulating the Earth's surface and preventing heat from escaping into space. Tyndall's experiments involved measuring the ability of various gases to absorb and transmit radiant heat, using a sensitive thermopile and a rock salt prism to analyze the absorption spectra of different gases. His results showed that whilst oxygen and nitrogen, the major components of the Earth's atmosphere, were relatively transparent to infrared radiation, carbon dioxide and other trace gases were effective at absorbing and trapping heat. Tyndall's discoveries not only validated Fourier's earlier theories, but also laid the foundation for understanding the potential impact of human activities on the Earth's climate. As industrialization and the burning of fossil fuels increased atmospheric concentrations of greenhouse gases, the implications of Tyndall's work would become increasingly evident in the decades to come. Building upon the pioneering work of Fourier and Tyndall, Swedish scientist Svante Arrhenius took a significant step forward in quantifying the potential for carbon dioxide emissions to influence global temperatures. In 1896, Arrhenius published a groundbreaking paper titled On the Influence of Carbonic Acid in the Air Upon the Temperature of the Ground, in which he calculated the effect of varying levels of carbon dioxide on the Earth's surface temperature. Arrhenius's calculations were based on the principles of the greenhouse effect and the known absorption spectra of carbon dioxide. He estimated that doubling the atmospheric concentration of carbon dioxide could potentially raise global temperatures by 5 to 6 degrees Celsius, that is 9 to 11 degrees Fahrenheit. While Arrhenius's initial estimate was higher than later calculations, his work represented a significant milestone in recognizing the link between human activities, specifically the burning of fossil fuels, and global warming. Arrhenius's findings were met with a mix of skepticism and curiosity within the scientific community at this time. However, as industrialization and fossil fuel consumption continued to increase through the 19th and 20th century, his pioneering work would lay the foundation for understanding the potential impacts of human-induced climate change. These early scientific pioneers of the 1800s, Fourier, Tyndall, and Arrhenius, may not have fully grasped the magnitude and complexity of the climate challenge that would unfold in the centuries to come. However, their groundbreaking discoveries and theories provided the essential building blocks for our current understanding of the greenhouse effect, the role of atmospheric gases, and the potential for human activities to influence the Earth's climate system. If you found this video interesting or useful, we'd really appreciate it if you gave it a like. And if you'd like to hear more on climate history, climate technology, and climate accounting, we'd love it if you'd subscribe and enable notifications. Finally, if you're interested in developing your environmental and sustainability skills, we offer the friendliest climate courses in the world. And we're offering 10% off all courses with the code YouTube. Click the link in the description below or head to footprintconsulting.org/courses.